The first one loads the library, and the second one's launch the DSS. So let's see, by default, CoLa will use your default web browser. For that, in my case, it's Microsoft Edge. But right now I want to show you some messages. As long as I run CoLa, here I have a get working directory. So this is the working directory that R is having right now. There's some messages about the packages, the versions, conflicts. And we have my files will be stored in CoLa. My temp folder is going to be CoLa NSA, and timestamp, and my temporal RDIR are those. So whenever you have to check temporal files or whatever, you can go and check what is the message here. Let me stop that. I will stop CoLa and run again. And you will see that because already load all the packages, we don't have all those messages here. So let me go back to R, and here we have where is my files, where are my folders. And here in CoLa, remember, we have a previous name before, CoLa NSA. Now my folder, my temporal folder is CoLa MUVX. And here in CoLa, probably we'll have two folders. So whatever we made is going to be stored here. The name is long, but it's created in order to avoid collisions and duplicate folders. So it's a timestamp with a prefix that is easy to navigate. Now we are in the decision support system. Let me extract this window for you. And now we can make a very, very quick tutorial. At this point, we have everything installed. Now it's working and you should have no problems. Now, for users that only want the command line and Python and don't want to use R, you should first get Anaconda or Miniconda. And once you have it, you can follow these steps. So you need to install an environmental manager for Python or Conda. Could be Anaconda, Miniconda. You might need Git for that for that approach. Please save your local installation. You need to know where it's going to be. Save that information. Now, in the command line on the prompts, you need to check your version, see that it's working correctly. Then you need to create a CoLa environment. There is a command line that you need to copy and paste. In this case, Conda in blue are the commands, bright blue. In red is the name of the environment, is CoLa, and the libraries or dependencies are in the royal blue. This procedure might take maybe 10 minutes. And then whenever you have your system installed, you can list where your environment stored. Then you need to clone the repository, download the script essentially, or you can download that from the GitHub as we did. This is the option B. Go to the repository and download the zip file. And then you need to download and uncompress everything. And it's in R, already know where is the script and where is the executable. You need to create that command line on your own. So I will show you how an example of that in a minute. But before that, I will finish the procedures here. So at this point, if you have issues, please refer to the manual. If you have a problem that is not reported, please fill the form. Now let's go to a tutorial about how to use it. Let me jump into the fresh window that we just created. And here we have the software at the left. And we are going to quickly see how that works. So the first step is having us converting our suitability into resistance. That requires a rasters. The rasters needs to be projected. But if you don't have one, we can have Andrew Hearn sample data set from his research. We have a suitability raster here, and I will cover those details in another video. But at this point, we need to run the function. We're going to keep all the parameters by default, and whenever I hit run, R is going to create a command line. The command line is Python. Where is my Python? Where is my script? Which one is my input? Which one is my output? And which parameters I'm using for it. So that structure that goes to Python is the one that you want to replicate if you're using only the command line. So the structure is, again, where is Python? Where is my script? My input, my output, and my parameters. So an example of that is the following text. Let me copy this, and we can have a replicate of that in here. So, example of backend. So this is the example of the structure that we need to copy and paste. And here is the one that we are using that is actually working. For us. So let me split that into Python. So we need Python, the executable file, which is here, the scripts, second line, input, third line, output, fourth line, and the parameters existing, the remaining lines. So we need to use full paths. It's important that there's no spaces. As you can see, the space separate arguments, but a space in the path will split an actual argument into two. So that's why we don't can have spaces in our users. So if I copy this file, well, right now we have that our result, a surface resistance, is stored here in CoLa MVX. And if we go to the whole folder, here's our raster. So we are writing that this is the location of our raster, but if we want to download it again, we can just copy that file into our particular location of our computer. So at this point, we can see that the CoLa is working. We have suitability, and now we have a resistance. Let's simulate some points, maybe 50 points, based on the best conditions of the raster. So right now we have a gray screen that means that it's working. In the backend, in R, you may see that this also represents a command line that is running. We have the points now, and with the points and the resistance, we are able to create the corridors or the kernels. So let's use a random number here. It's only for demonstration. Please be patient. Wait until the screen are not gray to run again the functions. And here my intention is to show you that Python is being executed in the back by R. So we have here again another command line. And let's say that we want to run this particular, create this corridor that use this command line. You can see how the corridors were made. But instead of using that parameters, I want to change, let's say maybe another parameter. And I can just copy and paste here. Okay, say just run. Let's see if this works. Or maybe go to the prompt command line. command prompt. So let's say I want to run the same command line, the same function from the backend. This is how it looks like, but instead of 1 million or 1 million, I will use maybe 2 millions, and instead of 0, let's say it's 10. You can get familiar with the parameters later. But here I'm running conda from the backend, and I'm going to hit just enter. Oh, sorry, I have to interrupt because I'm using the same name, so I need to change the name. So this is out LCC manual command line, maybe command line. Here we go. I was attempting to overwrite the existing document. So we have some warnings from GDAL. It's not ideal, but in some computers happen, in some does not. In my case, it had. So now we have seen that it took 7 seconds to run again. And let's see if that was produced. So yes, the out LCC was produced here. And we changed the parameters, so it returns a wider corridors. And that's how we can run the backend of Python. Now, there's another way to run it. And since we have this, let me just go to an example of that. For this, I need to stop the front end. So we can see that now it works. We can download the raster that is in that folder. We can just download it, that is, make a copy of that in another folder. So we have that in our downloaded folder, but that's a copy of the file that exists already here. Now, how can we run that in the backend? For that, I will recommend you to go and visit CoLa user manual. Let me go back. Let me go back. Actually, yes, we can access that via the DSS, but here there's a link to the user manual. So open a new tab. Whenever you have launched the DSS, you can go to the home tab and users manual, and there's is a local version, but the living document, the actual document, is in this link. So you need to click and open a new tab, or it will just go to that tab in this, to that web page in this tab. So you don't want to lose your actual session. So open a new tab and you go and visit your document, which is the same here. And here you can go and check, navigate to the parameters, sorry, to the documentation of the function. So how to run the corridors? Well, here's a description, what are the parameters? And here we have an example of how to run that in the backend and how to run that in the front end, in R. So I will show you briefly how I run that, even it's not for this video, but run LCC. So I know that my corridors are equal to LCC by, and I know I have some parameters. I have inship file. I have initial TIFF. I'm just adding the parameters. I'm going to put that in a minute. A number of cores. Okay. So the input here, the first input is what is, and in R, the arguments are given by name. So you need to put which is one and the actual value of them. But in the command line, they are by order. So you can switch the order. In Python, it needs to be first the Python file, the script, the input, the output, etc. You need to check the documentation.